Hello, Walter Godsil here from Rawhide Leasing. Rawhide Leasing supplies CNG, compressed natural gas, and other industrial gases through our tube trailers, high pressure tube trailers. The tube trailers are 2,500 psi to 2,900 psi, and they have a capacity of up to 160,000 cubic feet. In order to reduce that pressure of 2,500 psi down to a working pressure for whatever your application is, we use a regulation trailer. This particular regulation trailer was built by Tom Savage, and this morning Tom's going to walk us through the setup and operation of this trailer. Tom?
How you doing? Let's from the beginning, this is the high pressure inlet side. Right now we're temporary, just have it set up on a 300 cubic foot cylinder. Normally it would be to one of these high pressure vessels, the 140 to 160,000 cubic foot trailers. Basically we're capable of handling multiple trailers through here. Let's just say this would be your primary trailer. When that trailer lowers down into pressure, we would switch over to this line here, say, or possibly this line, but this one's set up with a union ready to go.
So I could have up to 3 trailers connected to this.
Absolutely.
And when the first trailer is depleted, you'd shut that one off and then switch over to
switch straight over to this one, yes.
And no interruption in flow.
No. You can have 24-hour non-stop flow.
Okay.
Right now we do have the high pressure turned on right up to the valves at this point. We'll send the gas through the filter into the first cut. Basically we'll be taking the 2,500, this is at 2,000 or a little less than 2,000 right now, and we're going to set this, a standard setting on the first cut would be 400 psi. That's a very versatile psi to work with on a first cut.
Okay.
The higher, when you use high pressure applications, we can go up to 1,000 psi on that first cut for high usage, surges, pushing equipment, pigs through pipelines. But just for a delivery rate into a pipeline, if a man wants 50 psi, I usually stand by 400 psi as a starting point.
So if we're going to cut this at 400 psi to start, that means that when the trailer approaches 400 as it's depleting, that 400 psi is as much as I'm going to be leaving 400 psi in that trailer, and it's time to switch over to a new trailer.
Yes, and for the filling purposes, usually we shut those down at about 800 psi.
Okay.
You do not want to have, you'll start losing your cubic footage going through your trailer. Exactly, your volume will drop as you start balancing out.
Okay.
Yes, so 800 is a point where we switch over different trailers. Not only that, it makes filling the trailer easier, a quicker process than draining it down complete.
Okay, I understand.
So we do have the pressure on right now. When I open up these valves, I don't just rip them open. I crack them slowly and let the pressure build. Once it's on there, you can tell by the free movement of the valve that it's definitely pressurized. You can tell by your high pressure gauge that that's where we're at right now, is about 1,800 psi.
So this gauge is going to read the exact same pressure
as your trailer.
Okay.
Yes.
Okay.
Yes. Now, the first step is, in order to set this regulator, this valve must be in the closed position so you can tell what you are balancing out here. You turn this to the increase. You can see it climbing. These become very sensitive as you get up there in pressure. A little twist goes a long ways. Now I've achieved the 400 on the outlet pressure. So the first thing you'd really like to keep an eye on is to make sure that this is not rapidly increasing. If so, you have a problem with the seat in this first regulator.
Oh.
If you see that climbing up,
okay. Now, I understand you have a redundant system here too, that this is your primary system, and then the redundant system is the one above it. It's just exactly the same as the one below, is that correct?
Absolutely, yes. Like this one, I actually have it a little set over a little 400 right now. I will set this one at 400, 395 to 400. If one was to fail, the other one would take over.
And when you say fail, that means perhaps you get a frost and a little bit of water in one of the seats and it freezes up
Yes,
and
you could shut down and actually repair the regulator if necessary and continue to run on the other line.
Okay.
So we can do that now also, is take this one, being as that one's a little over 400. First off, I gotta
open the valve.
I always start these out in the closed position. Very important. It's very important that way you're not, from what the manufacturer says, it's a lot better on the seats. We've got the high pressure valve in the closed position. Increasing the pressure here to we'll leave that one right there, a little under 400, a little over, a little under.
Okay. So this is pretty much automatic then. If this system fails, then it just automatically picks up the gas, because as long as one gas is higher than the other, then you're going to be using the higher pressure.
If it fails, you will know by the pressure relief,
okay,
which is set at 550 psi. If it does fail, which granted we can put different pressure relief valves on there for
right.
high pressure application, up to 1,000 psi.
Okay.
This one is a 550 just for general purpose. General 90% of the work that we do.
I understand.
If you were to hear a pressure relief going off, you could instantly come and see that you have a regulator that's in the failing process.
So then
that's when you would shut it down.
At the valve here, and then your
exactly. If you isolate it between here and here, this regulator can be repaired while running on the upper regulator, or vice versa.
Okay, I understand that. I've never seen a regulator quite like this in a big box. What's the situation there?
It's wrapped around a catalytic heater. These regulators get extremely cold. Basically, it's very possible they could have 140 below zero gas going through them. The higher the pressure that you have on your tube trailer, and the lower the cut that you make this, you gain, I don't know the exact figures, but I'm going to say it's 7 degrees per 100 pounds.
Okay.
Basically, though, if you're trying to cut it 2,400 pounds, that's the temperature that it will frost. These regulators, they do have a piston in them, and that piston will get stuck in the upward position where it will not regulate.
So this is wrapped in a catalytic heater so they can
Yes.
keep that warm?
Yes.
Oh, there's actually a catch there. You can open
Yeah.
it up.
Which one of the first steps of using this, before you'd ever really flow any major amount of gas through it, is we would turn on these heaters.
Okay.
Because we want that preheated beforehand. We do not want to jump on a job, start flowing 30,000 cubic feet with a stone cold regulator. It'll fail before we get very far.
I understand, but isn't it kind of dangerous having a heater on natural gas?
Oh no, this is very sealed. Everything in here is sealed and
But there's no flame of the catalytic heater.
No,
that helps out on it.
Yes, there's
Okay.
no flame at all. It's a 12-volt system that basically warms a catalyst. Once the catalyst gets warm, we feed them with low pressure, compressed natural gas. This particular unit runs on 4.5 water column inches.
Oh, okay, that's not hardly any gas at all.
No.
So when I go to light this, you said a 12-volt battery. You mean we don't have to use a barbecue lighter?
No, actually, there's a 12-volt deep cycle battery in here.
Yes?
Make sure that you have your battery hooked up, positive and negative. It's very simple, just like you would on your car. These regulators are all labeled. This one would be 3, this one is such as 4. I would turn this on in 4. It takes 10 to 15 minutes for the catalyst to warm up. So if you keep time on it, we'll watch it, and we'll actually turn that heater on here shortly, just to show you how it works.
Okay, very good. All right, so we've taken our first cut, and we're up to this part in the system right now. What's next? Where do we go from here?
The next step is, depending on the application, if a person is looking to have a consistent flow at 30,000 cubic feet or less, we like to run through the atmospheric vaporizers, which That is this valve right here will take the gas, it'll hit this valve, it'll shoot this direction, go through the inlet, through the vaporizers, out into this vaporizer, through the outlet, back to this direction, feeding onward. This is warming the gas.
So it's like a heat exchanger. You're taking cold gas in there, and those aluminum fins are transferring the heat,
exactly,
and warming it up. Okay.
Yes, and they work very, very well.
How much gas can you flow through those vaporizers?
We've done as much as 30,000 cubic feet an hour through those.
Okay.
And they're rated less than that, but we have done that before.
Okay. Okay.
Now, if we're going to go that way and we're going to feed it through the atmospheric vaporizers, my next step would be to, first off, I would feed this through. Now I'm putting 400 pounds to this area right in here.
Okay.
Now the gas.
So there's 400 pounds going through the vaporizer now. What's the maximum pressure you'd want to run through that vaporizer?
They're capable of handling, they're capable of handling more than 3,000 PSI.
Okay.
Yes. Now, we, like I said, we have a pressure relief here for 550 pounds. If we were having a problem right now, it would be popping off.
Okay.
But notice the gauges are still right roughly where they were at when we started. Okay, the next step is we've got the gas going in, supplying the atmospheric vaporizers. Now it's coming back on the outlet return.
Okay.
I'll take this valve and I'll open it up.
So we proceeded back completely through the vaporizer now, and the gas is?
The gas at this point is to right here, and we still have the 400 PSI. This line here is a very handy line. This is an auxiliary line. We use this for high pressure applications up to 1,000 PSI for pigging purposes, high usage purposes. You know, basically if somebody wants to get a lot of gas, a whole lot of gas real fast, this is the line that we use. We bypass this because we can't get more than the 30,000 cubic feet through the vaporizers. The bypass and the high pressure auxiliary line is really what we use for high demand situations.
Okay. And that the only situation with that is that you would not be able to control any kind of temperature. It's just going to be what it is.
Exactly.
Okay.
What it is what it is on that particular deal. You're not really warming the gas to any degree.
Okay.
But at this point, we still have the 400 PSI. We're coming into our second cut right here. This regulator is a Fisher, and I'll feed it. Now I've got gas going into the regulator. The adjustment is...
So there's 400 PSI going into the regulator, and now you're going to make an adjustment.
Yes, I believe that these are set somewhere around 50 right now, being as it's on here. Now we'll open up the outlet, which is pressurizing this manifold. Now I've got gas to this point right here.
And that gauge means that the outlet pressure of this regulator is preset to 50 PSI.
Yes, yes, and adjustable.
If I wanted to adjust that and raise it or lower it, what would I have to do?
If you wanted, let's just say we'll lower this one. You loosen up this bonnet nut, if I can. Now to see, I'll purge the gas out.
Bleed the pressure out.
Let's just say we're going for 40 PSI. A little low, so I'll increase it, and that would have my 40 PSI right there.
Okay. Okay. That seems simple enough.
Very simple. And depending on the application, we have different springs. We can, you know, take this from 5 pounds to 150 pounds max.
And we're still warming the regulators.
Exactly, yes we are. You know, if you're in a cold situation, these actually have to be turned on also if you're flowing quite a bit of gas in a cold climate. This one is not near as critical as that first cut because we are only taking 400 PSI. We're only taking a 350 pound cut right here.
Right.
So you don't have that 7 degree
heat
exactly.
I understand. Okay, great. You've got some other valves here. I noticed this small one that's running through. Is that what feeds the
Yes.
catalytic heater?
Yes, yes,
Okay.
it is. Now the gas comes back around into this manifold and basically feeds another Fisher regulator. This regulator, we set this usually at about 15 to 20 pounds, feeding this regulator, which we drop it down to the 4.5 water column inches to feed the heaters themselves.
Oh, okay.
And that is the final cut, which the bottom line is we can go from our flux, we have a range of 1,000 PSI to 2 water column inches, basically. So it's a very, very, versatile piece of equipment. If I was, I don't know if we kept track of the time as far as the heater goes right now, but
we may be getting close on that. But I have a question. You mentioned water column inches. I'm used to looking at gauges. What's
water column inches are a way of reading PSI when you get to the fine line of less than a PSI. Basically, I believe it takes 28 water column inches to make a pound. So these heaters are running on less than 1/4 of a pound.
So that you actually put some pressure on water and you make the...
Yes, yeah. To get the accurate reading, I would take a mark from the end of this stainless line right here, and I would put a mark at 4.5 inches. I would dip it, submerge it into a bucket of water, and I'd adjust this regulator to get that 4.5 inches. It has to be in the complete. It can't be kicked one way or another, but directly straight down in a bucket of water. When it produces bubbles at 4.5 inches, then you're set at 4.5. If you have bubbles just raging out of it, it means that you're probably cranked up. You have to decrease your pressure.
I understand. Okay.
But they have been set. I usually set it on that very first regulator just for the simple. I always put a mark on there at 4.5 inches when I build them, when I'm testing them, and that usually stays there the whole length of the trailer. So if a person really wanted to test that, that regulator up front's the one I usually test it on at the far end of the line.
Excellent. That looks like a pretty well thought out program here. It's self-contained all the way through, that you're going to take 2,500 PSI and regulate it down, keep everything flowing until the trailer's empty, right out to the end here, and you can adjust all the way through.
Yes.
Can you use this for nitrogen or any other gas too? Would you want to use it for any other gas?
We have never used it for nitrogen, but I don't see why a person couldn't use it for nitrogen.
Okay.
You would run into a problem of running your heaters. You'd have to have a source of compressed natural gas just to feed the heaters.
Right, I understand.
But no, it would regulate nitrogen, helium, whatever gas in or gas you want to really run. But this trailer was basically designed for natural gas.
Okay. Well,
at this point, we have turned on that heater, and it is feeling warm to the touch. At this point, I will feed gas to that, which the gas is coming through, just like I said, through the backside here, going down, and I have it reduced at this particular point to 4.5 water column inches.
okay, Tom, it looks like we've got gas coming all the way out here. The gauge is pressured up. It's got a header here. Where do we go from here? What's happening?
Well, if we were going to feed a pipeline, per se, and the desired pressure was 40 psi, we would hook up a lower pressure hose to right here, feed it into their pipeline. It's 1 inch. We usually are looking for a 1 inch connection, whether it's a female, male. It doesn't matter to us. We usually have the fittings to do this. Not a problem, but it is a 1 inch outlet hose on this.
Okay. And this is going to be the primary valve then once they're connected.
This will be the one that once you're pressurized and they say, we're ready to turn on the pressure, this is the valve that I operate with.
Okay. And since we're using CNG, natural gas, instead of just that line, however long that line is, going to have air in it, just regular air that we're breathing right now. So somehow we're going to have to purge that line. So we'll use natural gas to purge the line out on their end of it. We'll get all the natural gas out, or make sure it's full natural gas, and then we're ready to go.
Absolutely, yes. You want to purge it at the far end, at the where your inlet is to whatever pipeline or a piece of equipment that you're feeding.
Okay. I noticed there's a couple extra fittings here. There's
this is basically for regulator adjustment, a purge. It's a simple purge just for I'm not going to get you. It's a purge for basically getting the air out of the system in between the trailer, your tractor trailer, and getting all the air through your vaporizers and getting pure gas to this point. These can also be used for testing the purity of the gas, which some companies like to do. This is
ordinarily you have a fitting pointing this up in there so you don't hit me in the air with it.
Normally I don't have somebody standing around talking to me.
Okay.
This one here is basically, I like to, it's a dirty leg. If there's any debris, condensation and whatnot after the end of the job, I like to drain that down, which, you know, debris will come out.
Okay, I understand. And then extra fitting for just auxiliary?
That is an auxiliary plug right there. And let's just say that the people or the piece of equipment does not have a pressure relief and they want to protect it. We can actually add a pressure relief for very ultimate protection of their equipment or their pipeline.
I understand. Okay.
If let's just say if we're running at 40 psi and they can't have more than 50 psi, we could put a 50 psi pressure relief on here to protect their pipeline or equipment.
Okay. Excellent. And then the auxiliary line, did you have any more that you wanted to add on?
The auxiliary line is basically the same. This is your main control valve. It's a 1-inch hose, depending on, basically our 1-inch hoses are 1,000 psi rated, so they are capable of handling all that we can put through this. This would be the main valve for that. If I was, in this particular situation, a person always has to remember, you can put 1,000 psi to this point. To run the heaters, you have to keep this valve open. That is letting the gas circulate through just to protect that heater and keep it warm. But if I wanted to shoot 1,000 psi, I would increase my regulator here, open up this valve, and I can adjust it right there too. That's my delivery pressure. This gauge here is on the line itself.
Okay.
So a lot of times you lose pressure in the length of the hose that you're feeding and whatnot. I can tell exactly what I am feeding their equipment, their pipeline, off of that gauge right there.
Okay.
I might be reading 1,000 here. It might only be showing up as 900 here.
Understand. Okay.
Just from the, you know, this is static pressure. That's residual pressure once the gas starts flowing.
Okay, excellent. Okay, Tom, tell me, how can we tell it's hot?
How can we tell? Basically, you can either use a thermal gun or just common sense. These Cadillac heaters get up to about 750 to 800 degrees. They're definitely, you can feel the heat coming off of them. Once that you have had the power on for 15 minutes, you feed the gas through and you feel that warmth coming out of it. At that particular point, you shut off your power source. You do not need the 12 volt. You do not need to be sending the 12 volt power to the catalyst anymore.
Okay.
The gas will take over at that point.
Okay. And once that starts warming up, and it's going to be 800 degrees, if you have this box closed, then that whole thing is going to warm up to, it's like an 800 degree oven, isn't it?
Yes, yes. And this is a problem we come into quite a bit. You know, being on standby positions, and we have taken a little bit too long, and now we've developed a pretty hot situation here. So a lot of times if I'm in a standby situation and they say, hey, we're not going to be ready for a half an hour or so, then I will take a piece of simple tin foil, wrap it around the backside, and protect this regulator. You do not want it to get 700-800 degrees.
So if you're not flowing gas through there and it gets too hot, you can actually damage the inside of that.
Internally, you will cook out the O-rings, the Teflon seat. It will cook it.
Okay. So the simple thing to do is just open the box up.
Open the box up.
Put a little piece of aluminum foil in there to shield it, and you're good.
That's correct.
Okay. I think we could handle that.
Yes, and something that you'll also notice is as your PSI on your inlet starts dropping, you're not creating that cold temperature through that regulator. And a person really needs to keep their eye on this regulator at all times, as far as, you know, pay attention to it, that it's not getting hot. Because say when we get down to the low pressure, the 800 psi and whatnot, all of a sudden, instead of being 100 below zero, we might be basically at 32 degrees, 40 degrees.
Okay. Because
we've lost that cut, that differential, which means the gas, the lower that
trailer
the
is,
supply
the warmer the gas is.
Exactly.
Okay.
Yeah, you're not cutting it as much.
Okay.
The tin foil, if I would pull that out as soon as a person said, you know what, we're going to fire up here in 5 minutes, I would let that regulator warm up at that particular point. When I know I'm within 5 minutes or so of flowing a considerable amount of gas, I will shut that door. That way, that regulator is internally warmed and it's ready to perform at that point.
Okay.
But it cannot sit on standby.
Closed like that?
No, it's not good for it at all.
Okay, I've got my trailer shut off, so we have no gas flowing from the trailer, but my line's still pressurized. So what's the procedure from there?
I would leave these valves in the open position, leave everything completely open just as you had it as you were running your equipment. Come back to the back. It's very important that you pay attention that you don't have any kind of situation where you could have a flame, power lines. I usually really pay attention to what I'm doing when I go to purge this out, because there is still quite a bit of gas in here.
Right.
So I usually crack that, let it bleed down. It usually takes, depending on the length of the hose, it takes a few minutes. If you can see, as of right now, if you're shut down, your high pressure gauge will start dropping. After the high pressure gauge starts dropping, the low pressure gauge will drop. And finally, when you're at zero down here, it's emptied out and ready for the road.
That's actually dropping pretty quick.
Yeah.
Okay. So my trailer's empty now. Once the trailer's empty, I'm able to start the disconnect at this end, so I can separate my hose from the trailer. And do you secure your trailer before it hits the road then?
Well, the first thing I would do after I have it decompresses, I would come back, close my valves. Now it's safe to unhook your hose at this particular point. Everything is good. I take the regulators, bring them back, completely close them.
No pressure on the springs?
No pressure on the springs. Decrease them the full amount.
Okay, now, do I have to worry about turning off the catalytic heaters, or are they they're going to...
They basically, when you shut the gas supply off, it shut the heater off.
And they just cool off on that?
Yes.
Okay. So once you've backed the pressure off your regulators, then you're pretty much set, ready to go.
Yes, it's basically ready to hook onto and take to the next job.
Hey Tom, that's excellent. I really feel comfortable. I feel like I could back my trailer up to your trailer, make the connections, pressure it up, make the connection on the other end, warm up the regulators, and I'd be set until the job's over. So I can't thank you enough for your time. I think you've done an excellent job on building this trailer, but I want your phone number if I ever need to call you, okay?
Thanks.